February 20th, 1943, north of the Kasserine Pass in Tunisia, a moment that stunned even veteran German tank commanders. What they witnessed that morning defied every principle of Wehrmacht doctrine. American Sherman tanks, 5 of them, emerged from the dust and chaos, separated by broken terrain, with no line of sight between them, and yet moved as one. No flags, no flares, no messengers, and yet every tank covered the other's blind spots. Every crew knew exactly where the others were. The Germans, sitting in their Panzer IVs, struggled to hear their own commanders through the static of their radios. Their 10-watt transmitters, impressive by 1930 standards, were nearly useless on the move. Most German tanks could only receive, not transmit. They were fighting blind. Meanwhile, the Americans were using a technology the Germans didn't even know existed. Frequency modulation radios, crystal-controlled, 25-watt transmitters in every single Sherman tank. This wasn't just a communications tool. It was the birth of network warfare. The transformation began quietly on July 22, 1941, when the U.S. Army standardized the SCR-508, SCR-528, and SCR-538 radio sets for all medium tanks. Back home, engineers at the Galvin Manufacturing Company, soon to become Motorola, were perfecting frequency modulation technology for battlefield use. The key minds behind this revolution were Daniel E. Noble, who envisioned FM in military vehicles, and Henrik Magnuski, the RF engineer who made it happen. Their creation, weighing 181 pounds, turned every Sherman tank into a node in the world's first battlefield network. The BC-604 transmitter offered 25 watts of output, while dual BC-603 receivers let commanders monitor multiple channels at once, something no German tank could do. But the real magic was FM itself. Unlike the Germans' amplitude modulation systems, prone to static, engine interference, and limited range, FM radios provided crystal-clear voice communication, even during artillery bombardments. It sliced through battlefield chaos like a knife. During Operation Torch in late 1942, this advantage was put to the test. American tanks landed in North Africa with SCR-508 radios and quickly demonstrated their superiority. The German Afrika Korps, although experienced and skilled, were crippled by outdated communication systems. In a 5-tank German platoon, only 1 or 2 could transmit. The rest could only listen. If the command tank was hit, coordination was lost instantly. At the Battle of Kasserine Pass, from February 14th to 24th, 1943, these American radios became the unsung heroes. Though the battle was technically a German victory, it revealed the devastating power of FM communication. U.S. tank crews, often strangers, coordinated across 50 miles, warned each other threats, and called in artillery with stunning efficiency. German intelligence officers were baffled. How were these American units staying in perfect sync? The truth was both simple and revolutionary. Every Sherman tank had a powerful, stable FM radio system. When U.S. armor moved into the mountainous terrain of Italy, FM radios again proved their worth. German radios failed completely in the twisting valleys and ridgelines. But American tanks, using their SCR-508 systems, coordinated attacks where visual signals were impossible. In the hedgerows of France, however, a fatal flaw emerged. Tank radios couldn't talk to infantry radios. The tanks used 20 to 27.9 megahertz, while infantry radios like the SCR-300 used 40 to 48 megahertz. The result? American soldiers couldn't warn tanks of nearby threats like Panzerfaust teams. But within weeks, the problem was solved. Tank crews began mounting field telephones and external ammo boxes, wired directly to the internal intercoms. By Operation Cobra in July 1944, this simple fix had transformed tank infantry coordination. That operation revealed the full potential of America's radio dominance. Over 200 Sherman tanks coordinated attacks via a seamless radio network. Artillery strikes arrived within minutes. German defenders, operating with minimal communication, were overwhelmed. They faced an enemy that seemed to react instantly, as if it shared one brain. The contrast was stark. German radio production was far behind. In 1943, they built 5,700 medium tanks, but only 2,000 FUG-5 radios. Most tanks had no transmitter at all. They still relied on visual signals and rigid hierarchy. When command tanks were destroyed, platoons disintegrated. In comparison, every American tank could act as a command vehicle. And it wasn't just the Germans. The Soviets had even worse problems. The majority of their famous T-34s entered battle with no radios at all. Lend-Lease programs helped a little, providing some SCR-508 sets for Soviet command tanks. But by war's end, only about 25% of Soviet tanks had radios. America had 100% deployment. This wasn't just a tactical advantage. It was industrial. Motorola Chicago plant retooled from car radios to battlefield systems. Each SCR-508 required nearly 2,800 precision parts. By war's end, over 50,000 sets had been produced, enough to equip every one of the 49,324 Sherman tanks built. The SCR-508 was more than just powerful. It was reliable. It operated on 12 or 24 volts, automatically adjusted power, and had interference suppression built in. In combat, this meant voice clarity, even under artillery fire. German radios picked up every spark from the tank's motor as noise, and the results were devastating. At the Battle of Arracourt in September 1944, the 4th Armored Division faced German Panther tanks with better armor and guns. But superior American radio coordination led to a 7-to-1 kill ratio. 281 German tanks destroyed for 41 Shermans lost. German intelligence never grasped the full picture. They attributed American coordination to training and discipline, never realizing that the real advantage was invisible, riding through the airwaves. By March 1945, during the capture of the Remagen Bridge, radio communication allowed the U.S. 9th Armored Division to call in reinforcements within minutes. German troops, relying on telephone lines that were routinely destroyed by Allied aircraft, couldn't respond in time. When the Ruhr Pocket was closed in April, 325,000 German troops were trapped, partly because their communication lines had collapsed. American radio-guided bombers had wiped out every German node of coordination. By war's end, American tanks were not just vehicles. They were connected assets in a combat network. German tanks, no matter how advanced in armor or firepower, fought as isolated individuals. That difference, connection versus isolation, was a hidden force that won battles. As Field Marshal Wilhelm Keitel reportedly said at Germany's surrender, "We knew how to build better tanks, but you knew how to make them work together." Whether the quote is real or apocryphal, the truth remains, America didn't just build tanks. It built a network. Every Sherman tank became a node in history's first battlefield communication web. And that invisible advantage, radio superiority, changed warfare forever.